Let's make a brain using items I found at Dollar Tree for less than $20. Let's get to it. I did get some. I did buy some Play-Doh. So we have Play-Doh. We're gonna see what we can come up with using the Play-Doh. And I also bought a bunch of random clay. So this is like air dry molding clay, and then these are the same but just smaller packets of it. So whatever we're not using, of course, we're gonna return, right? Of course, as long as you keep the receipt, you're all good. This is my nail polish for 4th of July. I did buy this random tube, like the water tubes and stuff, but I was thinking maybe like sticking the items on here, like the brain stuff, maybe even using this as the brain and just kind of like covering it up and stuff. I liked it because it has kind of like that texture that I'm looking for. Of course, we'll have to fill in the gaps and stuff, so we're gonna see what we can come up with. I am creative but not that creative, so this is my time to shine, I guess. My loofahs, I was kind of thinking like being creative and kind of like using this for it as well. So more clay, of course, and let's not forget to keep our receipt just in case. That I have here at my home is free games. So now the assignment says for this project you're required to make a 3-dimensional model of the human brain, and it could be out of any materials. So we're off to a good start. It says it has to be 8 inches long and 4 inches wide. It says your model must show all the major lobes of the brain and the major landmarks that are listed below. I have to record a video basically demonstrating everything, so I'm excited to do that for y'all. Let's get to it. Now, first things first, I do need a sort of, let's see, like I need a structure to work off of and just kind of like pin some stuff on it. Let's go ahead and see what we can come up with, okay? Cut stuff up, just get right into it. It's kind of strong, wow, okay. We'll work with it. Alrighty, so I got a bunch of stuff already. I'm kind of scared to do this, but okay, let's figure it out. Atlas down, thank you very much. Okay, be the frontal lobe. Oh my goodness, this is not working out in my favor. Let's just, okay. Look at what we got so far. It's kind of weird, but it'll be good, don't worry. Yeah, you're probably not worried. I'm the worried one, but it's okay. We will get this done. Oh, this is very gooey. Oh my gosh, this feels very weird. I guess I'm gonna put it all around as much as possible. Okay, it's kind of looking more like a brain now. We'll just kind of spread it out as much as possible. Don't want to see it. This is so weird. It's a huge brain too. Well, in my defense, a lot of human adult brains are very big. Not that mine's big or anything. I think it's normal, hopefully. But this is just an example of a big human's brain. And we're gonna have to work with it. Y'all can see this better, right? Let's see. I think it's coming out okay. I just want it to stick, you know. I want it to stick to. It needs to stick to. You're all good in the hood. Just kidding. Ignore that. Yeah, so now what I'm gonna do this time is massage it so that way it can spread out evenly. And go from there. This is a huge brain though. I've never like actually seen a brain like in person. Like a human brain, but I heard that they can get pretty big. So this is gonna be one of those big brains, okay? Just bear with me. This new technique where I'm like patching it up type of thing. And just kind of connecting the dots, I guess. Let me try to extend this so I can do this thing over here. God, I'm so happy. It's working out, guys. I'm so excited. Sorry, I don't know why I'm getting so excited over building a brain, but so fun, actually. You guys should try it. It's therapeutic a little bit, I'm not gonna lie. You need the whole back, but the front is almost done. So just trust the process. I'm gonna do this super quick, and then I'll be right back. Guys, okay, I have the finished brain. Look at that big brain. I feel like this side is a lot bigger, so I'm gonna use it as a frontal lobe. Now the frontal lobe, I did want to go over what it does. The frontal lobe is right here. Basically, it's located in the forward part of the brain, so right here, like I said. It's involved with reasoning, motor control, emotions, so that's the emotional side of us, and the language. So let's go ahead and put this on here. So honestly, I'm just going to stick it in. So this is the frontal lobe. Oh no, I should have done smaller flashcards, but it's fine. Now let's do the parietal lobe. The parietal lobe is the lobe that's located behind the frontal lobe. This one is like towards the top back of our brain. It does play a crucial role in the processing of sensory information, spatial reasoning, and language as well. It does receive and interprets the sensory data that it gets. So we're gonna go ahead and also tape it. Parietal lobe. So we're gonna go ahead and put it on the top back of the brain. So it's like, I wanna say it's kind of around here. So we wanna do like right here. Great, it's working out. The temporal lobe. Now temporal, think temples. So it's located on the side of the head, near the temples, like I said. It's associated with hearing, memory, emotions also, and some aspects of language. So notice how all of them kind of have like some similar qualities, but then it also covers a lot of other things. There we go. That's not bad, right? Okay, it's coming out okay. Yeah, that's good stuff. Now the next part I want to go through is the occipital lobe, of course. That's the last one. Where's my other part? Okay, so the occipital lobe is like the bottom, like back of the head, or of the brain. Sorry, it's located at the very back of the brain. It contains the visual cortex, and its primary function is to process the visual information. So whatever we are capturing with our eyes, that's being processed in our occipital lobe. Okay, so we're gonna go ahead and do our thing with the flashcard. Occipital lobe. Yes, there we go. That's good stuff. Okay, yay. The two big ones that we've been learning this semester are Broca's area and Wernicke's area. I feel like we always talk about them in class. Well, we're going to start with the Wernicke's area. It's very crucial for language production. This is going to be language production, not comprehension. That's coming up. But crucial for language production is Wernicke's area. And it's going to be towards the area of the occipital lobe and temporal lobe. Parietal lobe. Well, also temporal lobe. It's kind of like in between all of them. But we're going to go ahead and squeeze our flashcard between those. I definitely want to put it somewhere like right here probably. We'll make it work. We'll see. So let's just put it here. It should be a good spot. We'll be fine there. And then we also have the Broca's area, which is very important. Broca's area. This is very important for speech comprehension. That's where I was going at with this. Very, very important. And we always talk a lot about it in class. And I feel like our professor has put a lot of emphasis into the Broca's area, so it's very important, guys. Especially as a speech pathologist, we definitely want to make sure we target these two specifically, the Broca's area and Wernicke's area. Those are going to be very, very relevant in the world of speech language pathology. So, also the Broca's area typically goes, kind of like behind the frontal lobe and like on top of the temporal lobe, I want to say. Go ahead and put it like over here because it's kind of in between the parietal lobe, frontal lobe, not in between, but kind of like towards the center. So we definitely want to put it like over here. Okay, so far we have the frontal lobe, parietal lobe, occipital lobe, temporal lobe, Broca's area, and Wernicke's area. We are missing just a couple more. I do want to start with the closest to the frontal lobe, which are the precentral gyrus and the central sulcus. I can't pronounce stuff sometimes. It's central sulcus, aka the sulcus of Rolando. What is wrong with me? Take two. Okay, so it's a central sulcus, aka the sulcus of Rolando. There we go. That is the surface landmark of the cerebral cortex, and that marks the boundary between the frontal and parietal lobes. So, since we are marking a boundary between the frontal lobe and the parietal lobe, I want to do what's called a border here, and I'm going to go ahead and do it with purple. Let's just do purple. If I can open this, thank you very much. Okay, there we go. I took out my nails recently, so bear with me. Now I don't have any nails. I need to do my nails for 4th of July, so I'm excited for that. But yeah, let's go ahead and do a border around and see how far we can get. I'm just going to go ahead and do it like kind of like in the middle here. I'm doing kind of like this. And I'm not exactly sure. I'm looking at the diagram here, but I think it's going to be all the way to the temporal lobe. I'm not going to do it down there because I don't know if it goes down there also. So yeah, let's just do a border up to right here, not including that. And then I'm going to stick the toothpick directly on the border, so that way we can tell the difference. Okay, perfect. Alrighty, so we got the precentral gyrus, and again, it's the primary motor cortex located in the frontal lobe of the cerebral cortex. No, we weren't doing this one. Look at me in my frontal lobe not thinking. I'm just joking. It's a stupid joke. But this is the one that we're doing first. We're doing the border. Sorry about that confusion. Alrighty. Ignore me and my confusion. Sulcus, aka sulcus of Rolando, and it's a surface landmark of the cerebral cortex that marks the boundary between the frontal lobe and the parietal lobe. Okay, so we're doing that one. Go ahead and stick it on here, and we are doing the purple border like we talked about, so let's go ahead and stick it kind of like next to the parietal lobe, I guess. That's perfect. Alrighty, now we're going to go ahead and do the precentral gyrus. It's the primary motor cortex located in the frontal lobe of the cerebral cortex. It's primary motor cortex. So we're going to do it over here. I don't think it needs a boundary or like a border or anything, so I'm just going to do it over here. Capiche? Awesome. Longitudinal fissure, aka the interhemisphere fissure, is a deep groove that separates the two cerebral hemispheres of the brain. So it divides the brain in half, pretty much, left and right, and it facilitates their independent functions and specializations. It houses the corpus callosum. Corpus callosum. Let's go. Longitudinal fissure. So I'm just gonna go ahead and just do this. I kind of messed up because I should have put it before everything else, but it's okay. We will make a way through all this. So let's go ahead and do it. Fissure. I'm gonna go ahead and put it like over here, I guess, on like next to the occipital lobe. We'll just cover the parietal lobe, or these that are close to the parietal lobe. So the postcentral gyrus, it's a ridge just posterior to the central sulcus, and it's in the parietal lobe where the somatosensory, if I'm saying that correctly, somatosensory processing initially takes place in the cerebellum. So it's going to be somewhere back here. I'll go ahead and label it on here. Let's see. So we're going to do this. Also, I think I should do something specifically for the Wernicke's area. I should do it in the third Plato or something. So, okay, so we're going to do that. There we go. Postcentral gyrus. Let's get it. Then we have our angular gyrus, That one is located in the inferior parietal lobe. So its crucial role is in various cognitive functions, like for example, language processing, spatial recognition, and memory retrieval. It's a big hub for integrating information. So we're gonna go ahead and put it on our brain now. Okay, and I do want to go ahead and use some Play-Doh for this too. I'm gonna just put it like close to the, I guess close to the occipital lobe, but it's more close. It's more by the parietal lobe. Still in the it's still in the parietal lobe area, by the way. Just making sure. That is awesome. Okay, perfect. Okay, we got this. I think it's time to start putting our brain on the stem, by the way. So yay us. And then I'm gonna do this. Moment of truth. Oh my gosh, it's not bad. Look, guys, that's not bad at all. We love that. Okay, perfect. Oh, I'm gonna do a separate part of the brain. I'm gonna make this the cerebellum. Kind of have to make it a little bulky and stuff. So there we go. It's gonna be down here, by the way. It's good. Okay, that's not too bad. Okay, let me show you all. It's actually gonna be the cerebellum. It does coordinate voluntary movements, posture, and balance. It ensures smooth and coordinated action. So we're gonna go ahead and. There we go. There's a cerebellum. All right. The brainstem is the one that connects the brain to the spinal cord. It's the region of the adult brain that includes the midbrain, the pons, the medulla oblongata, and it develops from the mesencephalon, and myelencephalon of the embryonic brain. Okay, so we're gonna go ahead and somehow create a brainstem. I think I'm gonna use blue. Okay, let's hope this works. Take a chance and do this. This is supposed to be the brainstem, guys. I'll show you guys a better. So I'm gonna stick this on the brainstem right here, guys. Bear with me. There we go. Perfect. Alrighty. And the superior temporal gyrus. Okay, so that's gonna be over here. I'm gonna label it with this gold. I don't have a lot anymore to label with, so I'm just gonna go ahead and do this. Superior temporal. Oh, this looks so cute, guys. Okay, that looks good. Okay, there it is, superior, and then we have the middle temporal gyrus. So this one's involved with language processing, semantic memory, visual perception of moving objects, and social recognition. It also has to do a lot with your emotional processing and expressions as well. Inferior temporal gyrus, now it's short for ITG, deals with visual processing, particularly in object recognition and semantic memory. It's also a part of the ventral stream that identifies like what objects are. So let's go ahead and put this on here. This was going to be towards the bottom. So, and again, inferior means below, like, you know, kind of like the lowest point. So inferior definitely is going to be below the middle and below the superior point of the temporal gyrus. So this is just to distinguish like 3 different ones, but obviously this has no correlation to the longitudinal fissure or whatever. Stick this one on as well. So that's the inferior. We also have the Haeckel's gyrus, aka the transverse temporal gyrus. Go ahead and put it by the superior temporal gyrus. So close by to that it should be. Definitely fact check me. I'm pretty sure that's where it's at. I looked at lateral fissure, aka the Sullivan's fissure. It's a deep groove in the brain that separates the frontal lobe and the parietal lobe from the temporal lobe. The role in functional organization mainly. It does differentiate the primary motor cortex from the primary somatosensory cortex. And it's going to separate all of this, kind of like that. I'll do blue. Let's do blue. Okay. Something like this. Oh my goodness, just started pouring down rain. Wow, it came down hard. Oopsies. The lateral fissure. So let's just do that. There we go. Perfect. Alright, guys, everything. Okay, y'all, so my phone's about to die, but I'm going to give you guys a little tour of the brain structure that I created. Just be very gentle with me. This is my first try, and I actually did not label it the way that I was supposed to. I should have made smaller little notes for the, like, to label them, to label each, just see if I can work with this for now. But let me show you guys. So the front, we have our frontal lobe, which is very textury, like I said. I love how it actually worked out as the brain. Don't mind the little bumps there. It's kind of weird. But then we got our Broca's area. I love this part. Broca's area is very important. We talked about how it is very important for speech comprehension. So that's awesome. Then we got our precentral gyrus. It's a primary motor cortex located in the frontal lobe of the cortex. So all of this is in pink is going to be in the frontal cortex. And we also have our central sulcus, aka the sulcus of Rolando. It's a surface landmark of the cerebral cortex that marks and boundaries between the frontal and parietal lobes. So I kind of did the little boundary right there. And we also have, oh, we already talked about the Broca's area, but then we have our temporal lobe, which it goes deep. Let me just show you guys the temporal lobe. Think temples when you talk about temporal lobe, but it definitely has a lot to do with like language and you know, it's just associated with like hearing and stuff like that. I already explained a little bit more, but then we got our lateral fissure on the side right here. It divides the frontal from the parietal and the temporal lobes, so it's right there on the side. Then we have that golden yellow. It's going to be called the superior temporal gyrus, and then right behind it, it's going to be the Heigel's gyrus, aka the transverse temporal gyrus. Then next to that is actually going to be the middle temporal gyrus, and then our inferior, which is the bottom, like lower part of it. And I labeled those with different colors there, as you can kind of tell. Our Wernicke's area is very important for language production, so it's right there with the gold. Very important and for a speech pathologist to know this. And then we have parietal lobe and back here, and we have our postcentral gyrus as well. And then we also have our occipital lobe and our longitudinal fissure in the back. I don't know if you can tell that line that separates the both hemispheres. It's going to be the right and the left hemisphere. Very, very exciting. And then I also did the angular gyrus right there, and I labeled it with the white, which is awesome. Ignore all my dirty dishes. I just made food, so whatever. But then on the bottom here, we have our cerebellum, which is going to be this over here. Coordinates like movement, balance, you know, posture, things like that. And I tried my best to add it on here, so it's that purple thing that you can see. And then we have our brainstem, of course. This is the region of the adult brain that includes the midbrain, pons, and medulla. There's a lot to it, of course. It does connect to the spinal cord as well, so yeah, so exciting. I wish you guys can get a better view of it. Honestly, yeah, it started coming apart just a little bit, but I hope that you guys liked my brain. Let me know any suggestions for the future, any other ways that you would have done it. I would love to hear any comments, suggestions, you know, jokes, anything. I'll take it. But this was a very, very fun activity. I really had a good time making it. So yeah, let me go ahead and show you guys this angle. It looks very weird, like a big burrito, but that's this angle. I should have done some things on this side too, but it's all good. It looks good. So there's our brain.